Hi everyone, in this video we are going to look at finding area under the graph. So we'll be looking at some examples on how we can find the area under a graph. Now we did this in class on page 32. We looked at how we can find the area under the graph. So the main thing I want to highlight is, in order to find the area under graph, we thought about it as, if I were to cut this into rectangles, how can I find the area of each of these rectangles and add them together? So if you keep that idea in mind, how do we find each of the areas? We take the height of the rectangle. How do we find the height of this rectangle? We take the y coordinate. We take the y coordinate of the point at the top minus the y coordinate of the point at the bottom. That will give us the height of each of the rectangle. So the y coordinate of the top of the graph will be given by y equals to fx. The y coordinate at the bottom is given by this line. In this case, this line is actually y equals to 0. So in other words, the height of each of the rectangles can be found by taking fx minus 0. Then we multiply by the width. Now with the width, we talked about how we want it to be a very small change in x. So we call that dx. So in other words, we add up the areas of all the rectangles together. So this is the height multiplied by the width. So fx dx. And we sum it up all the way from point A to B, when x equals to A, all the way to x equals to B. So when we integrate fx from A to B with respect to x, what we get is actually this shaded area. So this is what we have covered in class. We are going to see how we can apply this to questions. So on page 33, let us look at this first example. So I'm trying to find this shaded area. So you can think of it as if you were to cut this into strips of rectangles, right? How can we find the height of each of this rectangle? We take the y coordinate on top minus the y coordinate below. So this will always give you the right integral that you're supposed to integrate. So the y coordinate on top is given by this equation. The y coordinate below is given by 0. So we just take the y coordinate of the top minus the y coordinate of the bottom. Of course, for all the rectangles, so it will actually be the function x squared plus 4x plus 5. So this will be the y coordinate of all the points at the top. And then for the bottom, in this case, it's y equals to 0. So basically, we don't need to write minus 0. But anyway, it's actually subtracting the 0 for all the y coordinates at the bottom. Once we have this, we can write down the integral. So we're going to have to integrate x squared plus 4x plus 5 minus 0 with respect to x. I'm not going to write the minus 0. And we're going to integrate this from negative 4 to 1. Now, how do we decide the limits? You can look at where this shaded region is. The boundaries for this shaded region is from here to here. So from x equals to negative 4 to x equals to 1. So that's how you determine the limits. Okay, the next step would be to do the integration. So in this case, we have 3 separate terms added together. So we can integrate each of these terms by increasing the power and dividing by the new power. Now we're going to have to evaluate this definite integral. Now do note that because of these limits, this is called definite integral. And you will notice that because it's definite integral, we do not need to have a plus c in this integration. Now, how do we evaluate this definite integral? First, we're going to have to substitute the value of 1 into this expression. And then we're going to have to substitute the value of negative 4 into the expression. And then we will take the first expression minus the second expression. So it's going to look like this. Okay, so when we substitute 1 into the expression, and then we substitute negative 4 into the expression. And then we subtract this. This will give us the area under this graph, the shaded region. Okay, so the shaded region would be equals to 16 and 2 over 3. Okay, now let us look at the second example. In this second example, we are going to find this shaded region under the graph y equals to sine x. So you can think of again the rectangles that you're going to draw. Of course, if you are comfortable enough with this idea, you do not actually need to draw out this rectangle, but I'm drawing out just to illustrate. So I'll be taking the y coordinate of the top minus the y coordinate of the bottom of each of these rectangles. So this will be sine x minus 0, and I'm going to integrate this with respect to x. And the limits for this would be from 0 to pi. Then we integrate sine x. Integrating sine x will give us negative cosine x, and we can substitute the limits pi and 0 to evaluate this definite integral. Now when you are evaluating definite integral, always show your working. The working is basically the substitution of the top limit and the bottom limit into your integrated expression. Now cosine pi is negative 1. So negative of negative 1 will be positive 1. Cosine 0 is 1. So this is going to be negative 1. Therefore, this shaded area is 2 units squared. Okay, how amazing, right? You can find this weird shape area using integration. Okay, you can pause the video here to try these two practice questions before continuing to watch the rest of the video to check your answer. Okay, for practice A, similarly, if I were to look at the rectangles, I'll be taking the y coordinate of the top minus the y coordinate of the bottom. So this is the expression I'll be integrating with respect to x. Now we're going to have to integrate from negative 4 to 1. Integrating e power x will give us e power x. Integrating 1 will give us x. Now again, because these are just two terms added together, I can just integrate each of the terms. Then we can sub in our limits 1 and negative 4. Okay, then we can evaluate this answer. You can of course press this in your calculator to find the area correct to 3 significant figures, or you can leave the exact answer. I'm going to leave the answer in exact form because in case the question says leave it in exact form, you must know how to do it. So I'm going to demonstrate how, if the question asks you to leave in exact form, we can leave it in this form. So e power negative 4, we don't want to have negative power in our answer, so it will become 1 over e power 4. Then when you expand out this bracket, negative times negative 4 becomes positive 4. Then finally, there are some like terms we can add together. So if the question said leave the answer in exact form, I would leave this as my answer. If not, you can leave the answer according to 3 significant figures. Next, let's look at part B. So to find this area, I will need to look at my rectangle, top y coordinate minus the bottom y coordinate. So I'll be integrating 2 over 2x minus 1 with respect to x, and my limits are from 1 to 4. Now, how do we integrate 2 over 2x minus 1? Now, if you think about it, if I bring the 2x minus 1 to the numerator, it becomes 2x minus 1 power negative 1. And if I were to increase the power, if let's say I were to plus power, the power will become 0. And if I divide by the new power, I'll end up dividing by 0. And we know that's not possible. So whenever I do this and I come to this stage where we end up dividing by 0, that's actually the clue that tells me that this integration probably involves ln. So if you recap, integrating a over ax plus b will give us ln ax plus b. So in this case, I will need to check whether my expression looks exactly like a over ax plus b. Fortunately for us, this is 2x minus 1. So it is 2 over 2x minus 1, which is exactly a over ax plus b. Therefore, this will just straight away become ln 2x minus 1. I do not need a plus c, right? So I will just need to evaluate my definite integral. So I can sub in the top limit, which is 4. That will give us ln 7. And I sub in the bottom limit, that's negative 1. Sorry, it's positive 1. So when I sub in the bottom limit, I get ln 1. Ln 7 minus ln 1. Ln 1 is actually 0. So the answer is just ln 7 units square for the area. Okay, so the examples that we saw on this page are pretty straightforward. Let us now go on to the next page to look at how the area might look a bit different and how to find the corresponding area. Okay, for these two questions, we don't need to actually find the area. The question, we are just going to discuss how this area can be found. So let us look at part A, example A. So if I were to find this shaded area, the first thing I will go to is how would it look like if I were to cut it up into rectangles, right? So let's say the whole thing I cut up into rectangles. Now how can I find the area of each of these rectangles? I would need to take the y coordinate of the top graph minus the y coordinate of the bottom graph. So this should be the general approach. So in other words, what we need is the y equation for the top graph minus the equation for the bottom graph. So if I have this information, then I know what is the integral to get this area. Which means the question has given us the equation of this curve, which means one thing we will need to find is the equation of the line. Secondly, I will need to decide what's going to be the limits. So in order to decide the limits, I need to look at from what x value the area starts and at what x value the area ends. So you can see that it starts here and ends here. The x coordinate here is given as 3. So I will also need to find the intercept here so that I can get the x coordinate of this point here. Okay, so that will help me to find the limits. So in other words, what are the few things I will need to find? I need to find the equation of line. Once I have found the equation of line, I will need to find the x-intercepts of the quadratic graph. Okay, you can see that this point here is actually the x-intercept of the quadratic graph. So if I find the x-intercept of the quadratic graph, this will tell me what is the lower limit. Okay, so once I find these two information, I can find the area. So the lower limit is to be found, the upper limit is 3, and then I'll be taking the equation of line. So let's say the equation of the line is given by fx, then I will subtract the equation of the curve. Then this I will be integrating with respect to x. So that will give me the shaded area. Okay, now let us look at part B. For part B, again, similarly, I'm going to look at how it's going to look like if I were to cut it up into rectangles. Okay, so imagine these are all my nicely cut up rectangles. Now, how are we going to find the area of each of these rectangles? So if I were to take a rectangle here, I will take this y coordinate minus this y coordinate. Now, the y coordinate of the point at the top can be found by y equals to sine x, whereas the bottom part is actually y equals to 0. So I will need to integrate from sine x minus 0 with respect to x. However, how do I now decide my limits? You can see that the area actually starts from this point all the way to this point. So technically, these are the two values I should use for the limits. However, if you look at a rectangle in this region, right? If I were to take the y coordinate on top minus the y coordinate below, can you see that in this case, I should be taking 0 minus sine x? Because over here, how would you find the area of, how would you find the height of this rectangle? I would need to take this y coordinate minus this y coordinate, the top y coordinate minus the bottom y coordinate, which is different from how we did it for this first region. So in this question, we are actually not able to integrate directly from 0 to 2 pi. We should not be integrating directly from 0 to 2 pi because the two shaded regions, the area has to be found slightly differently. Therefore, we need to integrate this only from 0 to pi. That will give us the first shaded region. Maybe let me call this region A. Okay, so this first portion here will give us the area of region A. Now, how do we find the area of the second region? Let's call this region B. Now, if you recall, right, our sine graph, the properties of sine graph is such that region A and region B are actually going to be identical. So, of course, what we can do is just times 2 to this integral. That will give us the total shaded region. Okay, but let's say this particular the particular question, let's say the graph doesn't have this property of it being the same area. Then how else can we do it? Then we can find the region B by integrating from pi to 2 pi. So basically I'm integrating from pi to 2 pi. Now for this region, I'll take the y coordinate of the point at the top minus the y coordinate of the point below. So I will need to take 0 minus sine x. Then integrating each of these expressions will then give me the total shaded region. Okay, so the key idea here is that we are not able to integrate directly from 0 to 2 pi because the top graph and bottom graph changes within this region, within the two shaded regions. So there was a need for us to split the integral into two separate integrals. Okay, with that in mind, I'm going to just write down the integral for these two practices, and then you can try doing the integration on your... you can't do the integration because it's an unknown a, so we will just practice writing the integral. So in this case, if I were to cut a rectangle, I'm just drawing out all the rectangles to ensure that the top and the bottom graph is the same throughout. Of course, you can easily just observe it as well. If not, you can draw it out to see that the top graph stays the same throughout the region, the bottom graph stays the same throughout the region. So how can we find this area? We take the equation of the top graph and we need to take the y coordinate of the bottom graph. So I need to make y the subject of this equation first. Then we can integrate from 0 to a. Of course, if a is given, the value of a is given, then we can find the actual area. But here, because a is an unknown, we will just leave this as our answer. Okay, next for part B, similarly, I'm going to cut these up into rectangles. So all that matters is that the top is the same throughout this graph. The bottom is the same throughout this graph. Okay, so it's the same graph at the top all the way in this region. The bottom graph is the same all the way throughout this region. Then in that case, there's no need for me to split the integral. I can integrate directly from -1 to a. Now I'll need to take the top graph, which is given by negative e power x, and then subtract the bottom graph that is given by x minus 5. So this will give us this shaded region.